This section is on rational exponents, and rational basically is another word for a fraction, right? A rational exponent is a fractional exponent. So we're going to talk about how we can go back and forth between radical form and exponential form, and how we can manipulate exponential fractional exponents like we did with the radicals. All right, so if you have radical x, this is the square root of x, right? It can also be written as x to the power of 1/2. All right, now, how does that happen? Well, it's because, remember, we've always said that here there is an index of 2. So what you can do is you can convert a radical into a fractional exponent, all right? And when you do that, whatever the index here is, it becomes the denominator of the fractional exponent. So, for example, if I had cube root of x, it would be x to the power of a fraction 1/3, right? Whatever the index here is, it becomes the denominator of the fraction. So what would this be? 4th root of x. X to the power of 1/4. Now, what if, right? What if you had another power? So what if you had the cube root of x squared? Now, it's x to the power of something over something. Now, what's the denominator going to be? 3. And this power, it becomes the numerator. All right? So suppose I had 4th root of x to the 5. What would that be? X to the power of what over what? 5/4. All right? So always remember that the index becomes the denominator and the power becomes the numerator. All right. Questions? You can do the same with numbers. So if you have the cube root of 27, right, you could rewrite that as 27 to the power of 1/3. Now, what if you're just starting out with 27 to the power of 1/3? What does that mean? Then we could also always go the opposite direction, right? Where the denominator becomes the index. So 27 to the power of 1/3 is really cube root of 27, which is just 3. All right? Okay, so let's do a couple of examples here. So here I have a to the power of 1/5. Now this is a denominator. Is it going to become the index or the power? It's going to become the index. So it's going to be 5th root of a. All right? So here, we want to put this in radical form. Now, the d goes inside, right? Where does the 7 go? Inside. As a power. And what about the 4? It becomes the what? The index. All right? So always the same. Questions? All right. How would we write the next one in exponential form? C to the power of 1/8. And here, c to the power of -5/3. All right? Well, we're later going to learn that we actually are not allowed to have negative exponents. For now, we're just rewriting. I'm just going to leave it at this point, okay? All right, now, when you do have a power like this, right? We said you could write it as, like, so this one, we could write it as cube root of 27 to the power of 2, like this, right? Now, you could either do it that way, or you're also allowed to take that 2 and put it outside of the entire root. All right? So for example, if I have 4th root of, if I have 2 to the power of 5/3, right? I can rewrite this as cube root of 2 to the 5, or how else can I write it? Cube root of 2, the whole thing to the power of 5. All right? So this numerator that was going to become the power, it can either go inside the radical or outside the entire thing. More often than not, it's more practical to do it the second way if you have to evaluate numbers, because it's easier to deal with the numbers that way. They don't get too large. All right? Yes.
How do you figure that one out?
Why is it that way?
Do you do 3 times root 5?
So you do the parenthesis first, you do cube root the number first, then you raise it to the power. We're gonna do an example right now. It'll be order of operations. All right, so let's take a look at this one. Now, I just said earlier that you're not allowed to have any negative exponents. Okay? And what do negative exponents do? So let's go back to our Algebra 1 days. What happens with negative exponents? If I have 2 to the power of -3, how can I get rid of that exponent? How can I get rid of that negative? How can I make it positive? Well, I can make it positive, but the price I have to pay is I take the reciprocal. So it has to be 1 over 2 to the power of 3. Remember? So 1 over 8, exactly. So when you had, for example, a squared b to the -2 over c to the -3. Do you remember what we did in cases like this? Whatever is on top and has a negative exponent moves to the bottom, and whatever's on the bottom moves up. So the a squared is good. It doesn't have to go anywhere. Where does the b to the -2 go? Bottom, and it becomes b squared. And what about the c? It goes to the top and it becomes c cubed. All right, so that's what we're going to do here. So 49 to the -1/2 then will be 1 over 49 to the power of +1/2, right? And what's exponent of 1/2? It's going to be the square root of 49. Well, but it's going to simplify now. What's the square root of 49? 7. So this will be 1 over 7. But you're right. If it was something that wouldn't come out of the root, then you would have to rationalize.
Is that where you did the tree?
Okay, yeah.
Rationalize you do the tree.
No, rationalize is when you multiply by root x. Okay.
What's it called when you do the
Factor. That's the factor tree. Okay, so this one is 5th root of 32, and we're going to put the 2 all the way on the outside, right? Now, let's do order of operations. Parentheses first, then exponents. So inside the parentheses, 5th root of 32, let's see, it is 2. So this is 4 times 8, 2 times 2, 2 times 4, 2 times 2. Okay, 5th root says you group them by 5s. So let's see, 1, 2, 3, 4, 5. They all come out as a single 2. So here, the purple, it's just a 2. And now when I square, it becomes 4. That's your answer. Okay? All right? Okay. So go ahead and do this one. I'll give you a minute to do this one. I'm going to add in an additional problem. I'm going to sneak one in here. Okay, so go ahead and do that one. 81 to the power of 3 over 4. I'll stop this for a minute. So we have the 4th root of 81 to the power of 3. 4th root of 81? 3 to the power of 3, 27. All right, let's move on to these. We're going to add in one more thing, right, in simplifying. So one rule we're going to add is you are not allowed to have improper fractions. as exponents.
Improper fractions are moderate.
Not as exponents. Okay, we're not allowed to have improper fractions as exponents. All right.
What we did here,
So
like 7/4 in this one.
That was just for simplifying.
that was just for rewriting, right? Okay, so this one, all right, if I have the same base, different exponents, what do I do to the exponents? Add or multiply? What do I? You add them. Okay, so imagine if you had a squared times a cubed, that would be a to the what? 5. You add them, right? So here it's going to be y to the power of 1/7 plus 4/7, which is y to the power of 5/7. Now, is 5/7 an improper fraction? No. So we're good. We move on. All right?
Why did 7 or y?
Huh?
Does it matter if it's 7?
Yes, it does matter. So if the problem is given, as a rule of thumb, if the problem is given to you in exponent form, leave your answer in exponent form. If it's given to you in root form, leave your final answer in root form. All right? We're gonna just, as a rule of thumb, that's how it's gonna be for everybody. All right. So this one here, x to the -2/3, right? Okay, so first of all, we don't like that negative exponent. So it's got to be 1/x to the power of +2/3. Okay. Now, I'm not allowed to have improper fractions. I'm also not allowed, let me add that here, to have any sort of fractions as exponents in the denominator. Yes. All right. So yeah, this is a proper fraction, but it's in the denominator. No good. All right. So here's what we're going to do. I have x to the power of 2/3, right? I need to make this fraction a 1, 3/3, right? It's 2/3. It needs to become 3/3. So how many over 3 does it need? It needs a 1/3. So I multiply, I say times x to the 1/3. So the point is you just have to complete the fraction, right? Make the numerator and denominator the same. And you have to do the same thing to the top. So in the bottom, I now have x to the 3/3. And in the top, x to the 1/3. Well, what's x to the 3/3? It's x to the 1, which is just x. So I have x to the 1/3 over x. There we have it. Okay? That I can deal with. Okay. Here, what I want to do, I have 6th root of 16, cube root of 2. It's just a mess. All right? So the way you start simplifying is you have to get the radicand into the same base. The radicands have to be written in terms of the same base. So you have to make the bases the same. All right. Luckily, right, 16 is made up of what? A whole bunch of 2's, right? 16 is really 2 to the 4. Okay? And here we have cube root of 2. Now, at this point, when you've got different radicals, right, 6th root and cube root, but the bases are the same, it helps to write it in fractional exponent form. So let's do that. In the numerator, I'm going to have 2 to the power of 4/6, 2 to the power of 1/3. Okay? Is it possible to simplify the 4/6? Yeah, what do we get? 2/3. And here I get 1/3. Right? So let's see what we have here. 2 to the power of 2/3 over 2 to the power of 1/3. Now, we could do a couple of things here. I could multiply, right, here in the denominator like we did before. Or, what else could I do? What if I had a to the 5 over a squared? What would I do? Subtract the exponent. So let's do that here. 2 to the power of 2/3 minus 1/3. 2 to the power of 1/3. There you have it. Huh?
You can just subtract 1/3 by.
Well, just like in the first example, we added the exponents. In the second, in here, we subtract the exponents. Yeah.
How does 16 turn into 4?
It's 16 is 2 to the 4, right?
Yeah.
And then we write it as exponent form. So it's 2 to the power of 4 over 6.
That means it's 1 long.
So we subtracted the exponents.
Yeah.
If we have a to the 5 over a to the 3, it's just a to the power of 2, right? Because you subtract the exponents.
Yeah, but like what about you didn't subtract that? Yeah.
Well, I did 5 minus 3. You get one base, and you subtract the exponent. So if you had a to the 5, let's write it out. You have 5 a's, and here you have 3 of them. 3 cancels with 3, right? So you only get one base. Okay. Moving on. All right, let's see what we're gonna do about this one. Oh, one other thing. Sorry, I forgot my rule of thumb. Remember I said if a problem is given to you in radical form, keep the answer in radical form. So we're just gonna convert this and put it in radical form as cube root of 2. Okay. All right. Let's take a look at this next one. I've got a 4, I've got an x to the 4, and I've got a root 6. So let's change all of this into, first of all, let's change the numbers into their bases, and then we're going to do fractional exponents. So 6th root of, what's 4 made of? 2 squared, and this is x to the 4. So this is 2 to the power of 2 over 6, x to the power of 4 over 6. Simplifying, I get 2 to the power of 1 over 3, x to the power of 2 over 3, right? Now, my exponents are proper fractions, so I'm good. So this is going to be cube root of 2. Cube root of what? X squared. Finally, when you have the same cube root, you can combine them into the cube root of 2x squared. Okay?
Can you just multiply with 2x and
I'm going to rationalize this one. So I need to multiply by the conjugate. If I had root x plus 5 in the denominator, what would I multiply by? Root x minus 5. I have y to the half minus 1. I'm going to multiply by y to the half plus 1. Y to the half plus 1. Okay? All right. Check out what I have here. I have a minus b, a plus b, right? When I have a minus b, a plus b in the denominator, what's the shortcut? It's a squared minus b squared. So I'm going to square the first one, y to the half squared. I'm going to square the last one, and what sign am I going to put in the middle? A minus, right? Okay. So when I square this, y to the half squared, it'll be y to the what? Y to the 1, yeah.
So you bring down a -1, you square that, and then put.
You square the first, you square the last, you put a minus in the middle.
So is it in -1 that you bring down? Why are you doing -1?
Well, whatever. Well, when you square, it'll be positive.
Oh, you are
right?
squared it.
Yeah. So here we're gonna have y to the 1 minus 1. Y minus 1. Now, the top here, we need to FOIL this one. You could also do the shortcut. Let's just FOIL so everybody sees what's happening. All right, so the first terms give you y to the half times y to the half. That's y to the half plus half, which is 1. Y to the 1. All right. The outer terms is y to the half. The inner terms is another y to the half. And now the last terms, 1 times 1 is plus 1. Okay? Now, let's see what we've got here. I have y. How much is this? Is it?
Y squared, then y over t, so y.
What? Okay, so I have two different answers now. Who are we going with? So, if you have y to the half plus y to the half, as opposed to y to the half times y to the half, in which one do you add the exponents? The bottom one. Here's where you add the exponents and it becomes y to the 1. Here, you just have two of the same thing, so it's 2y to the half. So this is 2y to the half plus 1 over y minus 1. And we can stop there. All right?
No, we can't solve for y.
No. Huh? You would have. If you did the shortcut, you would have. I'll do it right now. All right. So take a look at this one. Here it's two fractions that we're multiplying, so we need to simplify. All right, we have a b on top and a b on the bottom. What do we do to the exponents? Add or subtract? Subtract. I have a c on top, c on the bottom. What do I do to the exponents? Subtract. So I have b to the power of, how much? 3 over 3 minus 1 over 3 is 8 over 3. C to the power of?
Wait, 3 over 3 minus 1 over 3?
Mm-hmm.
How can we make the b and 1 over 3 go up? Like,
Okay, so if I have a to the 5 over a to the 3, what do I do? It's a to the power of 5 minus 3.
but that's not below it, that's on the other side.
But it's the same. So they're fractions though, so we're multiplying them. So let's just rewrite this into one fraction, okay? Can we do that?
Yeah.
All right, so it'll be b cubed c over c to the half b to the 1/3, right? Now can we subtract the exponents? So it'll be b to the 3 minus 1/3 c to the 1 minus a half. So here it's going to be b to the 8 over 3 c to the 1 over 2. Are we done? Why not? We have an improper fraction. Okay, so how do we get 8 over 3? We have 3 minus 1 over 3. This is 3 over 1. So when you do common denominator, it'll be 9 over 3 minus 1 over 3, 8 over 3. Okay? Now, this is an improper fraction. It's no good. We got to get rid of it. How do we get rid of it? Well, how about if we do a remainder bit? What's 8 divided by 3? 2, remainder 2, right? So this is going to be b to the 2, b to the 2 over 3. So 2, remainder 2, 2, remainder 2. And it'll be c to the 1/2. All right, so here's one for you guys to do. Here's a couple for you guys to do. This one here is the answer. So I want you to simplify a couple here. I want you to simplify, a to the power of 17 over 3. And I want you to simplify b to the power of 9 over 5. And I want you to simplify c to the power of 12 over 3. All right? So 17 over 3, 9 over 5, 12 over 3. And I'll pause this for a few minutes. What would the first one simplify to?
A5, A root 5, and then A to the 3.
So where do a to the... So 17 over 3 is what? It's 5 remainder 2. So it'll be a to the 5, a to the 2/3. Okay? What about the second one? It's 5 remainder 2. All right.
Why would you do the 3?
Okay, so this is, it's 17 over 3.
You just take it down.
So you divide 17 over 3, it's 5 remainder 2. So it's a to the 5 and 2 over 3. Same denominator as that. So let's do that one. 9 over 5. 9 divided by 5 is what remainder what? 1 remainder 4. So it'll be b to the 1 times b to the 4 over 5. What about the other one? 12 divided by 3, it's just c to the 4. Do you see how that works? Huh?
Can you just write CB for this? Let's leave that also.
Oh, it's fine. Either way is fine. All right. So here we go. Here's a little bit of a summary. How do you know you're finished simplifying? Well, you know you're finished when you have no negative exponents, no exponents that are not positive, so no negative exponents in the denominator. When you don't have a complex fraction or an improper fraction, and when the indices are always the least number possible, right? So when all of these are simplified as much as possible. All right, that's how you know you're done. Improper fraction. All right, one more thing. Guys, look up here for a minute.